Okay, so I'm going to be going through the questions on the practice exam, starting with the true-false. So for the first one, there's one way that you can compute this, which is just to actually do the average rate of change between the 2 points. So this would be f of 3 minus 2 for 3 minus 2 because we're on the interval from 2 to 3. And if we put in these numbers, you can evaluate them in the function. If you put in 3, you get 7, and if you put in 2, you would get 5, and then divide by 1, and you get 2. And so the answer is false because it's not 1. The other way that you could do this is just to realize that for linear functions, the average rate of change is the slope, and the slope is 2, so we get the same number. Linear function always has one vertical intercept, that is true. And it's just wherever it goes through the y-axis. So yes, it always has one. A function is increasing if the output values increase while the input values increase. That's true. That's just the definition of what it means for a function to be increasing on an interval. Next, if you have the vertex and the 2 intercepts, it's asking you, is this equation true? And it is. It says that the vertex lies in the middle, in the horizontal direction, between the 2 horizontal intercepts. These are, and to clarify, these are the points x1, 0, and x2, 0, when we say the horizontal intercepts. Okay, next, 2 linear functions with the same slope intersect at 1 point. Well, what 2 functions with the same slope look like? Something like this, and they're parallel lines, so they never intersect, so it's false. Okay. Next one, this is just something you would compute. F of t minus h. So you replace every instance of t in the formula with t minus h, just like you would for a number. And we end up with sits t minus sits h, distributing the sits to the t and sits to minus h minus 1, and that's what it claims to be, so that's true. Next, what is the vertical intercept of this function? This might look like it could be true, but you need to be careful because if x is 0, which is how we find vertical intercepts, then actually we end up with 2 squared, or I should say negative 2 squared, really, plus 3, so I get 7, which is not 3, so the answer is false. So be very careful. If it's in vertex form, this 3 on the end is not the vertical intercept. Okay. If 2 linear functions have the same vertical intercept, then their slopes must be equal. That's not true. So if both functions intersect here, I can have them like this. Now, clearly these slopes are not the same. One's positive, one's negative, so the answer is false. They could be equal. It's not necessary. This function has horizontal intercepts at 1, 0, and 2, 0. That is true, because if I put in f of 1, I get 0, just because the first term in parentheses is 0, and the same if I put in 2, and so that's true. Zero product rule states that if some numbers multiply to 0, then none of them can be 0. This is actually the inverse, the opposite statement. If they multiply to 0, then it's not none, it's at least one of them. Would make that statement true. As it's written, it's false. Okay, the slope between these 2 points is 0. You just compute it. 2 minus 0, 3 minus 1. Yeah, it's 0. So that's true. It's a horizontal line. Okay, according to the vertical line test, which one of these can never describe a function? So what the vertical line test says is that if you have some function, maybe it does something like this, or some curve, if you can draw vertical lines and you end up with one that intersects the function, the curve, I should say, more than once, then the curve is not a function. So this would fail the vertical line test. So if we look at the choices here, that's actually, this is what I just said, that a vertical line intersects twice will make the curve not be a function. So if it intersects only once, that's fine. The test isn't even about horizontal lines. And if it never intersects the graph, well, then you're not really doing anything. But so the correct answer would be C. Okay, runner's distance to the finish line is described by a linear function. What is the slope representing? So the units for the slope are the units of y, the units of the output, which is feet, divided by the units of the input, which is t. So the slope is measured in feet per minute. Now, that immediately rules out A, because that's not even talking about a rate. It's not going to be B, because it doesn't even have the rate units as well. So it's either the average rate of change of the time spent or the runner's speed. Doing the average rate of change of time doesn't make any sense, because we do average rate of changes of a function and not just of like time or a variable. And so the answer is this. And the units for that make sense, because feet per minute, distance over time, right, is a measurement for a unit for speed. And so that made sense. Okay. This next one, this is something you would compute. F at x plus h, just like you did for the true or false. So replace every x in the formula with x plus h. Now this needs to be simplified a little bit. So 1 plus 2x plus 2h over 3. And that is option B. The horizontal intercepts are found by setting what variable to what? Well, if you want the horizontal ones, you want to know when the output is 0. So you want to set y to 0, and then you would solve for t to figure out right where when y is 0, what are the values for t? Okay. Which of the following describe the linear function passing through these 2 points? So these are all in point slope form. It would be helpful if you found the equation using that form as opposed to finding it in slope intercept and having to go backwards. So the slope between the 2 points, remember, y2 minus y1, x2 minus x1. So x1, y1, x2, y2. It doesn't matter which order you pick them, you just have to be consistent. So 9 minus 6 over 8 minus 2 is 3 over 6. And so the slope is 1/2. So it's not going to be C or D. And now the equation, you could either write it as in this way, depending what you've seen, 1/2 x, and then you can pick a point. You could either do this point or this point, but because the options, I think, are obviously in terms of 2 and 6, we should do that. So you could either write it like this, or you could subtract it, the sits to the other side, and write y minus sits equals 1/2 x minus 2. These are the same equation. It's just the sits is either on the right or it's on the left. And if it's on the left, then we can see that this is B. Okay. Write a formula for this function. So what are we doing? Let's cover it up. So you add 5 to the input. Okay, so we start with x plus 5. The next step is that you square it, the whole thing. So we can write it like this. and then you multiply that by 2. So you have a 2 out front, and this would be the formula for the function. Make sure that you do this in the right order. For example, if you you can't square it and then add 5, you'll do something different. So the order that this is written in the sentence is the order that you should be doing these operations. Okay, so moving on to like open response type questions. First, the amount of salt dissolved in the tank of water is a function of the volume. Okay, so this is the relationship. What does this statement mean? In other words, if you knew that the ordered pair 8610 was on the graph of the function or satisfies the function, what does that represent? So what this means is that the pounds of salt is S, it's the output from the function, and that's 86, and it's measured in pounds. Okay. The volume V is, I'm sorry, I wrote this wrong. This should be 10. Sorry, the output's 10 pounds of salt. The input, V, is 86, and that is in gallons of water. And so what this means is that 10 pounds, or LBS, 10 pounds of salt would be dissolved in 86 gallons. 86 gallons of water. Okay. Factor these equations. Okay, so or say that they cannot be factored. Spoiler, all of these can be. So you should get factorizations for all of these. So what do you need? You need two numbers that multiply to 6, the constant term, and they have to add to -5. Okay, so they have to multiply to a positive number, so they both have to be positive or they both have to be negative. And because they have to add to a negative number, actually both of them have to be negative. This isn't a process you need to think about when you do this, but it might help you narrow down some choices. Or you can just spot what they are directly. Here, either way, the numbers are -3 and -2, right? Because they multiply to 6 and they add to -5. And so we would write this as x minus 3, x minus 2. For the next one, it's very similar. Here, we need two numbers that multiply to -40, and they have to add to 3. So if they multiply to a negative number, one has to be positive and one has to be negative. We can pick 8 and -5 will work because 8 minus 5 is 3, and if I multiply them, I get -40. And so x plus 8, x minus 5. Notice that you cannot do -8 and 5 because they still multiply to -40, but 5 minus 8 is -3, not positive. So these two numbers don't work. There's only one answer. Right? Okay. Next one, multiply to 1. And they have to add to 2. That's just 1 and 1. So we could write it as x plus 1, x plus 1. So these two numbers are 1 and 1. Or if you want to really reduce it more, you could say it's x plus 1 squared. But either of those would be acceptable. For the last one, there's a trick if you notice it, that this is equal to x squared and 121 is 11 squared, which is a difference of squares. So remember, if you have x minus a and x plus a, this is equal to x squared minus a squared. So if you have a difference of squares, meaning you subtract, right, difference of two square numbers, x and another number like this, you already know what the factorization is. So here this would be x minus 11 and x plus 11. Now, if you didn't spot this, that's okay. You could still do it the other way. You would need two numbers that multiply to negative 121, and they have to add to what? They have to add to 0, because this is really x squared minus 0 times x minus 121, and these two numbers would then be negative 11 and positive 11, and then you just get back to this. Either way, you can do it. Noticing difference of squares, that was very efficient, is all. Okay, next, this value of a car. So it depreciates over time. How long does it take to drop to $1,000? So what this is asking you to find is to solve when v of t equals 1,000, not putting 1,000 in for t, but solving the equation for t. So 1,000 equals 18,000 minus 1,700 t. Now, you can go about this in a couple of different steps. At first, we should get to the same spot at the end. What I would do is add 1,700 t to both sides. So 1,000 plus 1,700 t equals 18,000. And then I would subtract 1,000 from both sides to end up with 1,700 equals, 17,000. And then I would divide by 1,700 on both sides. So I would get t 17,000, watch the zeros, over 1,700, and that is 10 years. So it takes 10 years for the car's value to go to reach $1,000. Okay. Next one here, we have the population of a town 2 years after 2000. 3,600 people are present in the year 2005. So what this means is that the ordered pair 5, because it's 5 years after 2000, and 3,600 is on the graph, and then in 2020, so 20 years later, there's 7,400 people. So maybe this isn't necessary to write out, but if this helps you to visualize what's happening with the formulas and such, it might be useful for you. So from these, the slope is, again, y2 minus y1. It doesn't matter the order you pick. So 7,400 minus 36 over 20 minus 5 gives us, you can do this on your calculator, 253.33 for the slope. Now, you can do point slope form. So there's two choices here. If you did that, P of t equals 253.33. T minus the t coordinate, the x coordinate. And you can pick either point. In the solutions we did 5, but you could do the other one. It doesn't matter. What I mean with the other one is that I could have done, in here, I could have done 20, and this number could have been the other ordered pair. You'll get the same equation. They look different, but they're exactly the same, so it doesn't matter. Okay, so you can do point slope form, and then you get that. If you didn't want to do point slope form, that is fine. What you would do at this point is say, well, I know the slope is 253.33 t, but I don't know the vertical intercept, b, and so then you would substitute in a point, say the first one, but it doesn't matter. You could do the other one. 3600 253.33 times 5 plus b, and then you can solve for b, and you would get, this is something to do on your calculator, well, we can multiply these numbers out. So 253.33 times 5 is 1266.66 plus b, and then this means that b is 3600 minus 1266.66, and this is a lot of threes in this question, 2333.35, and this means that the formula plus 2333.35. So either one of these would be fine, or you could use the other point, the point slope form. It doesn't matter which form you want to have your answer in. There's just two different ways to go there. Okay, determine if the following table is a linear function. So what you need to do is find the slopes between the consecutive pairs in the table. So for example, the slope between these two ordered pairs. So the slopes between these 2 points would be 6 minus 4.4 over 5 minus 3, right? Change in y over change in x. And this gives us 1.6 over 2, and so I get 0.8. Okay, now we can do this for the other pair from 6 to 7.6. And again, I get 1.6 over 2, so I get 0.8. And again, 9.2 minus 7.6 over 9 minus 7. Yeah, I get 1.6 over 2, so I get 0.8. So because these are all the same number, it is linear. It's a linear function. Another way that you could have done this is to notice that the inputs are evenly spaced by 2, and the outputs are all evenly spaced. So to go from 4.4 to 4.4 to 6, I add 1.6 plus 1.6 plus 1.6. This means that it's linear. Or we can compute the slopes. Doing the slopes is a little bit more fail-safe, because if the inputs were not evenly spaced, then you would need to check slopes. So it's not a bad habit to do anyway. So the function's linear. The slope is 0.8, the number we just found. And then we want the equation. So if you did point slope form, you could do 0.8, say for instance x minus 3 plus 4.4. If you so that's one option. If you did slope intercept form, then this would be 0.8x plus 2. This is a very similar process as well, because you would say that y is 0.8x plus b, and then plug in a point and solve for b. And you get 2. Okay. So the graph of this function is given. What are all the inputs t for which t of f of t is 4? What this is asking you to find is all of the points that have an output value of 4. So that's 0.5 and 1.5. Where is it increasing? So it's increasing when the function is going upwards. So from here to here on this range, the function's heading up. And then from here to here, the function's also heading up. So these would be the intervals that we provide. And it has to be the t values, the input values for which this is true. So from 0 to 0.5, the function is going up, and also from 1 to 1.5. Where is it heading down? Where is it decreasing? On this piece, from 0.5 to 1, and from 1.5 to 2. So this would be 0.5, 1, and 1.5 to 2. Okay, ball is dropped from a cliff. The height of the ball is given by this function. What are the horizontal intercepts? So to find this, to find the intercepts, we set the function equal to 0. So 300 minus 16 t squared is 0. You can add 16t squared to both sides. So 300 equals 16 t squared, and then divide by 16. So just isolating for t squared. Now we can do the square root. So this means that t is the square root of 300 over 16. And if you do this on your calculator, it's 4.3301. The units would be seconds because it's the input variable, which is measuring in seconds. Now, there is another solution here. This is something we'll talk about more in chapter 4, because this is really plus or minus. The negative of this value will also satisfy the function. It is a quadratic after all, but it doesn't make any sense because in this problem, t is measuring time and negative time isn't something that we're considering. And so that's why this says the horizontal intercepts for when t is greater than or equal to 0. So this would be the only value in that would make sense for this problem. Now what it means is this amount of time after it was dropped it hit the ground, or hit the lake, I should say. Right, because it starts off with some height. 4.3 seconds later, the height was 0, which means it had to have hit the lake. So it took that amount of time, basically, to hit the lake from the cliff above. Okay. Next up, revenue is given by this function. It's quadratic, depending on the price of the item per dollar. So it's the amount of money the company takes in if they sell their product at a certain dollar value. What is the function in standard form? These parts are in this order for a reason. Each part should kind of help you, the subsequent one should help you with the next. They're kind of structured in this way. So if we want to write this in standard form, we need to expand out the p minus 4 squared term. So we can write it like this. What you cannot do is just like square p and square negative 4. That's not how exponents work. They have, if they are applying to something in parentheses over a sum, they have to apply to the whole thing. you're multiplying it by itself, p minus 4. So this is now, if we multiply this, p squared minus 4p minus 4p plus 16. Now all of this has to be multiplied by -1 because of the negative in front, plus 16. Now if we combine this a little bit and we multiply the negative through, we'll have negative p squared. This term, negative 4p minus 4p, is negative 8 times p. And when I distribute the negative, I get plus 8 p. And then I have negative 16 plus 16, so I have plus 0. And so the function is negative p squared plus 8p. How can we write it in factored form? This is why you had to do standard form first. So if you want to write it in factored form, the easiest way to do this is to recognize that there's a common factor of p in both of these, and that can be factored out. So if we take this out, negative p times p gives us back negative p squared. And if I factor out the negative p from 8p, I'm left with minus 8. So this works. You could have also just factored out p, not negative, and you would have got a negative p plus 8. These look different, but they're the same formula. It doesn't matter which one you have. In either case, it's the factored form for the function. So what are the horizontal intercepts? Now that you have it factored, this is quite easy because all we have to do to solve this is to set the function equal to 0. And then because it's factored, we can use that to our advantage and use the zero product rule. So that says that either this term is 0 or this term is 0. So solutions are 0. And when negative p plus 8 is 0. And so our conclusion would be that the horizontal intercepts are at p is 0 and when p is 8. Or if you want to write these in ordered pairs, you would say 0, 0, and 8, 0. Both of those are fine. And also to do this, I could have used this equation. So this one could have been used in this step, and you would have gotten the same answer. So it truly doesn't matter which one you use. So those are the horizontal intercepts. What that means is that if they charge those values, so if they set the item to either $0, they obviously make nothing. That makes sense. Or if they set it to $8, they also don't make any money. Maybe because at $8, no one buys it or something, and they end up with 0 revenue. So for this function, which way does it open, either up or down? If you look at the standard form representation that we have here, then the a value, the lead coefficient, is negative 1. So it opens down. Okay. And how do we plot it? So we know that there's an intercept at 0 and there's one at 8. That's what you found in part C. You know it opens down. Okay, so the vertex has to be somewhere up here in order for it to open down. And we can find the vertex. So H, we know the two horizontal intercepts. One of them is 0 and one of them is 8. So H is at 4. And the y-coordinate for the vertex to K is just the revenue at H. So R of 4. And you can put 4 into any of the functions, the equivalent representations that you had found above. Doesn't matter. If I put it into the first one that we had, it's negative. P is now 4, so 4 minus 4 squared plus 16 gives me 0 plus 16, so I get 16. So actually the vertex is at 4, 16, which is up there. So the vertex ordered pair 4, 16. So the graph would look something like this. Okay. Next, do these tables of values describe functions? So you cannot use the vertical line test because there isn't a graph. Given the table of values, the only way to figure out if it's a function or not is to use the definition of what a function is. So you need to look at each input. So does each input have only one output? If the answer is yes, then it's a function. And if the answer is no, meaning there's an input which has more than one output, different output associated to it, then the answer is not a function. This is what the vertical line test means. It comes from that. It's just a more visual approach given the graph, which we don't have. So for the first one, yes, because, well, each input only appears once. So definitely they all have to be associated with, right? There's never a case where the same input has two different outputs. Conversely, this one's not a function because the issue is one has an output of 0 and one also has an output of 2. Okay, that is why it fails. These ones are fine. They're not a problem. They're just duplicated. That's okay. The issue is that you have 1, 0 and 1, 1. Over on the right, yes, it's a function, and it's constant. Each input goes to 10, has an output of 10. The fact that they're all the same doesn't matter. The important thing is that you don't have an instance of, for example, 6, 11. Right? We can see that each input only has one output associated to it, and so it is a function. If you had a graph of something, of a function, which, for example, like this, you could use the vertical line test, and this is an example for where it would fail because these vertical lines, you only have to actually have one, but if there is more than one, then that also means that it's not a function. So because you have multiple intersection points, this is not a function. So it fails it would fail the vertical line test. For the next ones, we're looking at the domain. So in order to compute the domain of a function, you can alternatively find when what are values for the input x so that the function's not defined there. So because the domain, just as a quick recap, we could describe it as the set of all valid input numbers. When I say valid, I mean I can put numbers into the function and nothing bad happens. I don't break any rules in math. So this is what we're looking for. Now, the domain for these functions are quite large, so it's easier to say what is not in the domain or what is not a valid input number. And remember that when we have square roots, say for instance the square root of x, then we need x to be greater than or equal to 0. So this is just a rule that we have to remember, which will come up more in chapter 4, and it's applicable here because we're working with a function that has a square root. So for this problem, what we require is that the input, whatever is under the square root, has to be greater than or equal to 0. It cannot be a negative number. It can be 0, it just can't be negative. And so when we work with inequalities like this, it's similar to working with if it was just an equality, if it was equal to 0. There are some slight nuances that we won't go into, but it suffices here that you can just add 6 to both sides. So 2x is greater than 6, and then you can divide by 2, that's fine. So x has to be greater than or equal to 3 to make the function behaved, right? So that I can put in numbers and I don't break any rules. And so we would say that the domain is all numbers if you want to write it in words, greater than or equal to 3. If you want to graph this function on your calculator, you will see that it will not graph values of x less than 3, right? And that might confirm your answer. For the second one, the rule that we need to remember is that we cannot divide by 0. Okay, now that's applicable here. Hopefully we see why, because we have a variable in the denominator of this 1 over x plus 1. So it might happen that for some values of x, the denominator can become 0, and then we would be breaking a rule. So what we have to require here is that the denominator cannot equal 0, which just means that x cannot be negative 1. I can put in any other number I want, 1, 2, -1, -10, doesn't matter. The only one I have to take out is -1. And so we would say that the domain would be all numbers except -1. Okay. So there's no inequalities. It's not anything greater, less than, it's just everything but -1. Okay, now for the last one, are there any issues with this function? And the answer is no, right? Any number that I want, negative, 0, positive, a fraction, a whole number, I can multiply it by 2 and I can add 9. Nothing will break. And so the domain is the biggest that it possibly can be. It's just all numbers because nothing breaks it. The function is very well behaved. It's a linear function. Okay, for the last question here, the height is dropped from a bridge above a lake. So this is actually the same function that's in problem 24. We're doing something different here, but just to point out, it's the same formula. What is the average rate of change between these 2 points? So remember that the average rate of change, say from t equals a to t equals b, would be h of b. This is the formula we had, I think, in the true-false earlier. Like this. And so here, a is 1 and t is 4. So what we're computing is h of 4 minus h of 1 over 4 minus 1. Now these are values that you would put into the function. So if I put in 4, 300 minus 16 times 4 squared, you can do the calculation out. You get 44. I put in 1 to the function, I get 284. And I would divide that by 3. And the number that I get back is negative 80. And the units are the units of the output. It's the units of the slope, right? It's the same concept. So the output units, which is feet, divided by the input units, which is seconds. So the answer is negative 80 feet per second, which is a speed, right? So what does this mean? In the context of this, how we could do this in general for other problems. So we would want to say that from t equals 1 to 4, the interval that we're looking at, seconds, what is happening? So the height of the ball, the thing that the function's measuring, would decrease because we got a negative number. If we got positive, we would say increase, but that doesn't make any sense here, right? Obviously it's falling. So we would say it's decreasing on average by 80, and then the number with the units, feet per second. And we need to say on average by this amount, because it's not that for every instance of time between 1 and 4 seconds that is falling at this speed. It's that over the whole length of the interval from 1 to 4, it is falling at an average amount. So most of it's just what it sounds like. On average, it's falling by 80 feet per second. And we also wouldn't say negative because the fact that we got a negative number is already being absorbed and that we said it's decreasing, not increasing.